Hello and welcome. I thought I would give you a look at a practical use for the HP41. This is the HP41CX calculator with the interface loop and a couple of multimeters, a printer, a storage device, tape storage, and a constant current device. And I'm just basically testing batteries. So I've got a bunch of different types of batteries, rechargeables, you know, these ones here, N-size batteries, so these are ideal for these calculators here, rechargeable. And also the likes of testing these are the Top Cat style batteries that go into these devices here, the likes of the thermal printer and the cassette drive there, and the likes of these rechargeable any loops here. I use these as a kind of reference to make sure that my programming is correct, and because I know that these are a good battery. So fully charged, they're 750 milliamp hour. So if I get close to that, I know that my program and my setup here is pretty well right, and you know that's so I guess you could use that as like almost like a calibration. So yeah, I've got all sorts of different styles of batteries. That's the inside of a HP41C battery pack, a rechargeable one like I've got here. These are two 2.4 volt Vata cells, and I've used that to modify this little battery pack. They had, I think, 4 little, might have been sub AA's or something like that in them. Yeah, there's a modification you can do to upgrade this to get rid of the cruddy old batteries and put in nice new ones there. I know there's easy off-the-shelf ways of doing this, battery testing, capacity testing, things like that. I'm doing this just to play around really, you know, hone my programming skills and things like that with the calculator. I enjoy using them, I enjoy using these old devices, and yeah, I learn a bit along the way, so that's pretty good. And the reason for the testing is to verify these batteries. Like I've rebuilt this is a Top Cat battery here, and I've rebuilt that from imported subsea cells from AliExpress, I think they came from, and they don't seem to last very well. Surprise, surprise. I'm not convinced that these are 2500 milliamp hour. Now the thing is I've built them up. I didn't measure them prior to building this pack up. I've done several of these actually. If I have done a video, I'll link it in up here somewhere on rebuilding these battery packs. But the thing was, I didn't check these cells before I built these packs, and I started using them. They seemed okay to start with, but you know, eventually it seemed to me that the capacity was just dropping off very fast. And I'm just not convinced of the quality. I'm not convinced that they are true to label, 2500 milliamp hour. And so it's quite a good idea just to, you know, put them on the charger and give them a full charge, and then test them by draining them with this constant current device here. I'll get you in closer to each one of these devices just to show you a little bit more detail there. The other thing I wasn't too sure about is some of these cells that I got, they didn't have the little tabs on the end. Some of the batteries had this style of connection here with the little nub on it without tabs. So with the batteries that aren't tabbed, you're soldering directly onto the terminals, and that's not good for a battery, I know that. But I thought that I might get away with you know, doing it fairly quickly, and yeah, I just don't know whether I damaged the batteries or not. But I'm sourcing some tabbed ones, so I might go through and replace the ones that aren't holding a charge. But that's quite handy just for testing rechargeable batteries really. So if we have a close look here, I'll get you closer here. We've got the venerable HP41, that's the CX version. So that's got the real-time clock built in, and I've got a rechargeable battery pack here. That's a rebuilt one. That's pretty much what it looks like inside. I've cut the little wire there, so I've got this jumper wire here. So the weird thing is that I built 2 of these. This one here, in here, works fine, holds good charge. This one doesn't. So I've disconnected things and I've gone directly onto the terminals here and fully charged the batteries and done discharge tests. The voltages appear quite good when you just put a meter across them, but as soon as you load them up, they just don't last long at all. And these are good Vata batteries with little tabs on. I also grabbed another one out of the pack. This is a brand new one, and that doesn't seem to sort of hold much charge either. It starts off okay, but it really only lasts for about half an hour at about 100 milliamps. So that's half of its capacity really, and that's brand new. So I'm not quite sure what's up with these. Anyway, back to the calculator here. We've got a HPIL interface here plugged into there. If you're not familiar with the HPIL, there's plenty of information online, and I haven't done any specific videos on it yet, but just suffice it to say that you can connect a number of devices in a loop. So the thermal printer here, the HP4116A thermal printer, is device 1. We've got device 2 is the 3468A multimeter. Device 3 is the 3468A multimeter, and then we've got a digital cassette drive, the HP82161A digital cassette drive there for storage. That's not really required today, but we're using the printer and these two multimeters. And I've got the multimeters set up, so this one here is measuring volts and this one here is measuring current. Excuse all the wires and bits and pieces. This is really just a test rig, if you like. I might do a more permanent solution to make it a little bit tidier. But anyway, this is a constant current device that I built. It's based on a design that Chris Gamble did, and I'll link in his site down below. But basically this just puts a constant current load on the battery under test. Now these two wires here, the red and the white there, that's just the power coming from a bench supply I've got over here. That's providing power to the unit to power it, and then the unit itself is connected in series here with these two black wires. Leads up from, so one comes in from the battery negative and heads up to the multimeter measuring the current. And these two knobs here, the right hand one, pretty sure it's the right hand one from memory, that sets your current draw. So you can set it at say 50 milliamps or 100 milliamps, 200 milliamps, things like that, to draw the energy from the battery. The left hand one is the cutoff voltage. I don't use that, I use the multimeter to monitor the cutoff voltage. And if we have a look at our little setup here, I've got the two probes coming from the multimeter here measuring voltage. So this is set up really so that I can connect multiple different types of battery easily. I've got this one here set up for AAA, and then I've got a couple of loose connections here that I can just clip onto a battery holder. That's a AA battery holder. I can easily clip onto these types of batteries here. Just clip onto the terminals there, no worries. The Top Cat's a little bit more, these Top Cat ones are a little bit harder to measure because you can't really clip onto anything. So I made I just put a couple of loops. You can see these little metal loops here, and I can just literally sit the Top Cat battery on there, and gravity just holds it on there, and I can measure those. So just a little multi-purpose sort of setup there. I'll print the program listing. It's a fairly basic program. There's nothing too major going on. So if I execute PRP, which is print program, and then go into alpha and I put the program name in, which is, I've called it VTM, so that's volts over time. And we're just printing the listing here. It's nothing too technical, I can tell you that. I'll quickly show you the what's going on here. So the label, that's just the program name. Cell quantity, so it's prompting for the cell quantity here and storing that in 00, storage 00 there. Now the cell quantity is the likes of a battery like that is one cell. That's a 1.2 volt single cell. These are actually classed as a dual cell battery. That's 2.4 volt dual cell. And this one, these are 1.2 volts each, so we've got 4 cells. And the reason I put the amount of cells in there is because I want to set a threshold so that I don't over discharge the batteries. So I set the discharge threshold at about 1 volt. So it stores the amount of cells in 00, it prompts to insert the batteries, and then what happens here is it's actually selecting the multimeter that's measuring the current and executes a program to set that meter to measure the current. All it's doing here in this section here is triggering the meter and storing the measured current. It just does that once at the start of the program. So what you can do later is you can recall this from 01, and that will remind you of what the current draw was. So it's storing the start date in memory location 02, storing the time, memory location 03, and then we're coming down to a little subroutine here. That number 3 and selects the voltage multimeter and triggers a reading from the meter. It compares the result of this trigger here from the meter with what's stored in memory location 0. If it's over the threshold, it just loops back to label 00 and just goes through in this constant loop until the voltage gets down below the threshold that's stored in memory location 00, and at that point it just prints the end date, the end time, and a beep, okay, just to notify you that the test is finished and the program ends. There's more I want to do with this. This is just a very early revision. Okay, so I've loaded 2 AAA batteries here, rechargeables. They are fully charged. You can see there that the voltage is reading at 3 volts. Okay, so 1.5 volts each under absolutely no load whatsoever. So I've got this turned right down. Show you the execution of the program here. VTM, and it's prompting for the cell quantity there. I'll just put the printer onto manual there, I think should work. Cell quantity, 2 cells, and asking to insert the batteries. So what I like to do at this stage is I like to crank up the current load here. So let's go for, say, around 200 milliamps. Just try and quickly do that. It's pretty close. Run there. And now it's printing the time, the date. You can see the current draw here, 212 milliamps. It's printed the time, start time, and that will just go in a constant loop. Okay, so the program's running continuously here now, and that will just run in a constant loop. You can see that this meter here is being polled here, and you can see there that it's communicating. So when this reaches the limit that we set and stored in memory location 00, which will be the amount of cells, which is 2, when that reaches 2 volts, so each battery cell is down to 1 volt, this will kick out of the loop and end the program. And you can see here, you can monitor the current. So that's just set to constant current, 212. And then you can just do the maths and work out how many milliamp hours the batteries hold. And I guess from there you could do watt hours and whatnot as well. So yeah, pretty basic setup. And there's a few improvements I'd like to make. One is that I think I can send a signal to the current measuring meter to turn the meter off, and therefore I'm not sure if it'll break the circuit or not. I think it might leave the circuit connected and still drawing current. That's only really a problem if you're doing this unattended, because you don't really want to overcharge the batteries. So, you know, it would be nice if we could sort something out to actually just cut the connection. So I haven't experimented with that yet. We'll turn the meter off, but I suspect that the connections might still be running internally. I don't know. Or I could maybe switch it to a different mode, and that might disable this bottom terminal here. Just not too sure at this stage. So that's something I want to do. The other thing I'd like to do is add to the program so that it automatically calculates the milliamp hours and prints it here. So that's going to take a little while at 200 milliamps. So I'll come back when that's discharged, and I'll show you the printout that I get from there, and then we can do some calculations and work out to see whether we're fairly close to 750 milliamps for these new Anyloop Panasonic batteries. Okay, the program is finished here. I've removed the batteries, so we're not getting any reading on the voltage or the current there. And we've got our start time and end time here printed out. And if I have a look at recall 01, I think it is. Yeah, so 214 milliamps is what we started off with. And it maintained around about 214 milliamps. As I say, it's a constant current device. But I think, you know, temperatures and things like that affect it slightly. So I think it went down to about 210 milliamps. So it's not 100% accurate. There are other ways that that can be done. I actually had a program set up where the program would monitor the current constantly as well, and would calculate exactly how much current was being consumed, just to account for those slight variations. This is a lot simpler, a lot easier. And so we've got 0.21 there, and we've got a start time of 10:57 and an end time of 2:40. So that's 2 hours 43. If we take 43 and divide it by 60, we get 0.71. That's the 43 minutes, and it was 2 hours 43, so add 2. And then I'll take, if I just recall 01, it's 214 milliamps over 2.72 hours. Multiply that and we get 581 milliamp hour. Now these batteries are 750 milliamp hour. But these weren't fully charged. I really just grabbed the batteries I had and put them in there. But I've done tests on fully charged batteries, and they come out very close to 750 milliamp hour. I found another Top Cat that I haven't tested yet, so I'll go ahead and test this now. So yeah, you can see it's a fairly handy system just for checking the condition of batteries. I had these here. They're pretty old Fuji NiCads, and they, you know, you charge them up and they show full voltage under no load. So you know, it's not a very good test not putting them under load, but you kind of assume that they'd be okay. But as soon as you put just the slightest amount of load on these, they just die. And all four of them, I've got several of them in here, all four of them are no good. It's very old, but they do show a decent voltage when you start out. I've just imported these here. These are little Power Trust N cells here. Just came in through AliExpress, so I'll go ahead and measure those. They sit in the little pack here for the HP41 calculators here. It's quite a good option. I do like having the ability to just plug in the charger here to, you know, these packs here. That's a pretty good option. And that's what I showed you here. That's this little contraption here that I've pulled apart. But that's quite a nice option. Just means you don't have to pull the battery pack out each time to replace the batteries, and there's no risk of losing any programs that you might have stored. It's quite a convenient option. keep an eye out for more videos. I've been playing around with my 71B HP and also the 75C here. And I was going to do a video at some stage showing how you can transfer programs between these two devices using the magnetic strips. You can also use the cassette drive as well, which I showed you before over the back here, to transfer programs between those two devices. So that's something I've just been having a wee play around with. Also, I know that people are keen to see the microprocessor in action, so I'll be doing some videos just doing some very basic machine code programming on the Z80 chip that this runs on. So yeah, keep an eye out for more videos, and please subscribe. Click the little bell icon to get notified when I upload more videos, and thank you very much for watching.